The last type of reaction that you need to learn about is called a polymerization reaction, which just means making a polymer. Now, in order to understand polymers, if we break that word down, remember that poly means many. And so a polymer is made up of a bunch of what we call monomers, mono meaning one. So a bunch of these individual pieces are going to be put together kind of in a chain, and that's what forms our polymer. Most of the polymers that we talk about are plastics. That doesn't mean that they all are, and I'll give you some other examples later on of some naturally occurring polymers. But it does mean that there's many things chained together, and the most common thing is plastics, but there are others. There's two types of polymerization reactions that we're going to learn about it. So in this video, we're just going to look at addition polymerization, and in the next video, we'll look at condensation. So addition polymerization is very similar to addition reactions, where you have to have an unsaturated molecule to do the addition reaction, so an ene or an yne. In addition polymerization, our monomer piece has to be an ene or an yne. So let's start with a really simple one. Let's say we start with a ethene, and I'll name that here. So if that's our monomer, in order to make the polymer, in order to put these together, what happens is, I would say leave the double bond horizontal and bend everything else either up or down so it's out of the way. So I'm just going to straighten these hydrogens out, and then I'm not going to draw the double bond. I'm going to make that a single bond now. Essentially what we're doing is we're breaking that part of the bond, that one of the double bonds. And by doing that, remember that single bond was a shared pair of electrons, that frees up 2 electrons, one on each carbon, and they used to be forming that double bond. But in this case, we're adding more monomers, and so we add in another monomer like this with its paired or with its electrons. And now that those electrons are exposed like that, they can form a bond here between them. So if we were to draw the polymer with it all chained together, we wouldn't see that anymore. We would just see there's one attached to the next, attached to the next, like so. And then usually this would have like a dot, 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 dot on either side, just to tell us that that chain is going to continue in both, or has the ability to continue in both directions from that chain. When you're naming the polymer, don't look at the structure of the polymer itself. Look at the structure of the monomer. So the name of the monomer was ethene. So we call this polyethene. Now, the common name of that was polyethylene, but you don't need to know the common names of these. If I asked for a IUPAC name, you would just say poly, and then whatever the name of the monomer was. So in this case, polyethylene. All right, let's try another one that's a little bit more complex, but not a ton. Let's start with a propene monomer. I should have done. There we go. All right, so there's our propene monomer. And remember that when you try to draw this into the polymer, you want to keep that double bond horizontal, and you want everything else to bend up or down. So on that end, I'm going to bend the 2 hydrogens up on the right side. On the other side, I've got a hydrogen, but then I've also got another carbon with its hydrogens on there. Let me clear that up a little bit, like that. So I've bent everything up or down except for the double bond. Remember, then at that point, we break that double bond to create a single bond, like this. And it would have those paired electron, or those spare electrons like that. And then essentially you're just going to have that thing repeated over and over and over. You're just going to attach it together. So here's one of them. Here's another. And here's another. And then I would just put them together. Dot, 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 if I had room over there. And then fill in all of your hydrogens. So this monomer was a propene, so this would be called polypropene. Okay. Now the other way that sometimes these polymer questions show up is in the opposite direction. Rather than giving us the monomers and having us turn them into the polymers, sometimes they show us the polymer and we have to work backwards to find the monomer. So what if we had a polymer that looked like this? And actually, I'm going to pause the video here and draw this in just so you're not watching me fill all this in. Okay, so here's our polymer. When you see a polymer like this, the first thing you want to be looking for is what is repeating. So in this case, if you look, if we look on the bottom, we have fluorine, chlorine, fluorine, chlorine. So that repeat is kind of happening like this. Now we can kind of see the piece that would have been the monomer. So the next step for me is I take that piece out. So I have a setup like this. Another carbon up here. And then I start to think, well, I'm going to detach it from its other one. So essentially I'm breaking this and breaking this to separate the monomer from the polymer. And when I erase those two, I end up with, kind of working in the reverse here, I end up with an electron, nope, here and here. And then those electrons, rather than being broken and put out, we're going to put them back in. So they're going to move into here and form our double bond. So our polymer, or our monomer I should say, would have looked like this. Now if you wanted to straighten that out so it's a little bit easier to see, it would be something like this with a fluorine, double bond to a carbon, to another carbon, with a chlorine, something like that. So sometimes you're going to have to work from the monomer to the polymer, and sometimes you might have to work from the polymer back to the monomer and try to discover what that is. So hopefully you're comfortable with that. If there's anything there that's confusing, let me know. But hopefully that makes sense.